All right, in this video, we're going to use the remainder and factor theorem for dividing polynomials. So the remainder theorem is a way to determine if some polynomial division is going to result in a remainder. And a remainder theorem says if we have a polynomial function p and the degree is at least 1, so it's not a constant, if c is a real number, then when we take our polynomial function and divide it by x minus c, we're going to get the remainder is going to be the same thing as if we just evaluated the polynomial at this value of c. So let's take a look at an example so it might be a little bit easier on us here. So example 3, what is the remainder when 2x cubed minus 5x plus 3 is divided by x plus 2? Now, we could figure out what the remainder is by doing the polynomial division. We'd have to remember we have a 0x squared to fill in. So we could go through and do all the division and then figure out from there, okay, what's the remainder? However, the remainder theorem is a quicker method to do that. So for the remainder theorem, it has to be in the we have to be dividing by something in the form x minus c. So in this case, x minus c, we have x plus 2. The minus in front of the c indicates just take the opposite of what you see. And x plus 2 can be written as x minus negative 2. So the opposite of 2 is negative 2. And if we take that value of negative 2 and evaluate the function at x equals negative 2, that answer will tell us what the remainder is going to be. So plugging in a negative 2 for x, and doing the calculation, we get negative 3 in return. So if we went through and did the polynomial division with this problem, our remainder should come out to be negative 3. And in terms of how you can use this, you can almost use it to maybe, in a way, check to make sure that your answer is somewhat correct, especially if you have a remainder in your polynomial division that is just a constant, such as negative 3. So if anything, you can almost use it as a little bit of a quick check to make sure you didn't make any calculation errors in your division. Related to the remainder theorem is the factor theorem, and it says that if we have a non-zero polynomial, then a real number c is a 0 of the polynomial if x minus c is a factor of the function. So what this is essentially saying is you apply your remainder theorem. So we have, like x plus 2, so we plug a negative 2 in for x. If we get a remainder, that means that x plus 2 is not a factor of 2x cubed minus 5x plus 3. So if we were to factor this out, like you do in algebra class, one of those factors would not be the expression x plus 2, because if we use this remainder theorem, we get a negative 3 here. And in other words, when you put that value in, your remainder should be 0. So for instance, if you take 7 divided by 3, your remainder is 1. So 3 is not a factor of 7. But if you do 9 divided by 3, your remainder is 0 because 3 is a factor of 9. So if you apply the remainder theorem and get a 0 in return, that means that your expression, like the x plus 2, would have been a factor. So use the fact that x equals 1, so our value of c is 1, is a 0 of this polynomial to factor it and find all the zeros, all the real zeros of the polynomial. So in other words, if we take 2x cubed minus 5x plus 3, don't forget the 0x in the middle, and divide it by x minus 1, so we'll bring this over and make it x minus 1, this should have a remainder of 0. If it doesn't, then we made a calculation error because it's telling us in the problem that it is a 0, so it should have a remainder of 0 when we use the division. So dividing this out, we get 2x cubed and then 2x squared times negative 1 is negative 2x squared. That has to combine to make 0, so negative 2x squared plus 2x squared will give 0x squared. 2x squared divided by x is 2x. 2x times negative 1 is negative 2x. Negative 2x plus this term has to be negative 5x, which is negative 2x plus negative 3x gives us negative 5x. Negative 3x divided by x is negative 3. Negative 3 times negative 1 is 3. And notice if we combine everything, all these terms in the dividend are accounted for. So it does have a remainder of 0. So now to find the others, we can take 2x squared plus 2x minus 3. We can use good old quadratic formula on this. And when we simplify everything in the quadratic formula, we get x is negative 1 plus or minus the square root of 7 all over 2. So our zeros are at x equals 1 and x equals negative 1 plus the square root of 7 all over 2 and negative 1 minus the square root of 7 all over 2. All right, so that about does it for this video. Thanks for watching, and I'll see you next time.